Now 2.3, we have Venn diagrams and set operations. Here we have definitions. Set A is disjoint when they have no elements in common. So we have disjoint. That means there's no intersection between two sets, or we can say there's no members, no elements in common. A diagram of disjoint set looks like, okay, I'm going to draw that one. When we have disjoint, for example, let's assume that we have A and B, two sets. So this is Venn diagram. First, I have this rectangle. Now I'm going to draw two sets. One is A, the other one is B. As you can see, there is nothing in common because there is no intersection between these two sets. I don't know how many members I have here inside each one, but there is no intersection between these. So this is disjoint. Next one, sets that are not disjoint. I'm drawing Venn diagram for this one. Here again, I have set A and set B. Are not disjoint, that means we have intersection between these two sets, and that is here in between. So this is the intersection part. And that one is A intersection B. So this simple, this is for intersection. What that one means, we have members in common. Members or elements. Now, next one, when one set is a subset of another one. For this one, I will draw here. For example, this is set A, and I have another one that is inside this one. So B is subset A, but it's not exactly equal to. So we may say it's proper subset. If you want to have exactly what we had in 2.2, using all those that we did on that part, we can have also this part. This A and B. So I'm trying this way because you can see that we have actually two circles, two sets with same circle. The first one that we had here, this was B proper subset of A, and here B subset of A. The next one, the complement of a set A is all elements in a universal set that are not in set A. Now that we have this universal set here, here says universal set, what that one is. That is this rectangle. This rectangle was universal set having all members inside. Using U for universal set. Now I'm going to draw this one too. So we have universal set and we have set A. And complement of A, it's all the members that are outside of set A. So anything except A, that is complement of A. Or we use A prime as this one. So what I have inside that part is A prime or complement of A. The intersection of two sets A and B is all elements common to A and B. We already had that part here in this one. So you already had that symbol on top. So I'm going to redraw it. So it's A, and here we have B. And what we have in between that is intersection. Next one is union. This is the symbol that we have for union. It's same as U, but it's not U. Trying this one too. We have intersection and union in algebra. So this is A. For example, this one B. What union is all members. So combine all members that we have in A and B. We can have that one, or we can have this one also is union. A, B, and union is all members. We have in A and B. Next one, the difference of two sets A and B is a set of all elements in A that are not in B. So the difference of these two sets is elements in A that are not in B. That means we have to subtract A minus B. So any member that is inside B, we shouldn't have that one in A. We have to subtract all members that we have in B, subtract those from A. For example, if I have this one, A and B, and our answer is anything except those members that are inside B. So this is the answer for A minus B. I'm going to also draw what B minus A is. You know, this one is B minus A. So what B minus A means, we shouldn't have any members that are inside A. We shouldn't have those members that are inside A and also inside B. We shouldn't have that one. So we have to subtract all these members that are in A from B. So this is the answer. Next part, Cartesian product of two sets A and B is a set of all ordered pairs A and B, where A belongs to A, set A, and B belongs to set B. So this is A multiplied by B, multiply these two sets, it's Cartesian product of two sets. So in this part, what is given, A is 1, 2, 3, and B is 3, 4. Finding the Cartesian product is, this is the answer, but I'm going to explain how we got that one. Yeah, I'll write that one here. We already have the answer, but I'm going to write it. So our A was 1, 2, 3, and B is 3, 4. So this is given on that part. Now finding A multiplied by B. When I have, starting from left, when I have A multiplied by B, I'm going to list the members that I have for A first is 1, 2, 3. And here for B, we have 3, 4. Now finding product, starting from left, we have 1 goes to 3, 1 goes to 4. 2 goes to 3, 2 goes to 4. 3 to 3, and 3 to 4. Now I'm going to write all these. So it's 1, 3. Since we have ordered pairs, that means order matters. So I cannot write 3, 1. I have to write 1, 3 because we have A multiplied by B. So we have to start with the element that is from A first. So that is first. Then what I have for B is 3. So we have 3. Next one is 1, 4. And we have 2, 3. 2, 4. Then we have 3, 3. And finally 3, 4. Close set. Now I'm going to find B multiplied by A and see what is the difference. So first we have B. Elements are 3 and 4. And for A, we have 1, 2, 3. What they have here is, again, starting from left, starting from B. B times A is 3, 1, 3, 2, 3, 3. Again, B times A, starting with what I have on left, is 4, 1, 4, 2, 4, 3. I'm writing all of them. So it's 3, 1, 3, 2, 3, 3, 4, 1, 4, 2, finally 4, 3. Close set. Now let's compare these two sets. I said, since we have ordered pairs, that means order matters. 1, 3 is not equal to 3, 1. Now, comparing these two sets, do we have exactly same ordered pairs? We don't. Because A multiplied by B, we have 1, 3, but here is for B multiplied by A is 3, 1. Here we have 1, 4, but here is 4, 1. These are not same because order matters. In this case, A multiplied by B is not equal to B multiplied by A. Here we have set A and B, and also universal. So set A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have natural numbers starting from 1 to 10. And B is 3, 6, 9, 12, 15, 18. And universal set, this is in set builder. I'm going to write this one in raster form. So this is set builder because we have x such that x belongs to natural numbers and x is between 1 and 20. So let's write raster form. Here we have equal to, starting from 1. It's better to write this because this way is easier. It's easy to answer all these questions, but it's not required to write these if it's not asking you. So these are all the numbers that we have in this universal set from 1 to 20, because here we also have equal to. Now working on all of these. The first one is asking to find complement of A, but complement of A is we should have all members that are inside the universal set except those members that are in A. What we have in A are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We shouldn't have those numbers. So I shouldn't have these. What's left is starting from 11 up to 20. That is the answer for A prime or complement of A. Universal set minus A. So this way you can see what we did. Next one is A intersection B. What A intersection B means, we have to see if do we have any members in common or any elements in common between A and B. So these are in common, and the answer is 3, 6, 9. Next one is A minus B. So we shouldn't have these members here on this part. So we have to subtract them. It is 3, 6, 9. We don't have 12, we don't have 15, we don't have 18. That doesn't matter if do we have this 12, 15, 18 inside A or not. The answer that we have here is what is left in A after subtracting. After subtracting, the answer is 1, 2, 4, 5, 7, 8, 10. Stop here. Some students writing 12, 15, and 18. That is wrong. Because 12, 15, and 18 are not in A. We're not able to write them. Okay, I can write this one as, so you can better see what we did in this case. We had A minus A intersection B. But this is exactly the same as that one. So if it's hard to find out what is the answer, use that method. Find the intersection between two sets first, and then subtract that from A. Intersection was 3, 6, 9, and we subtracted those three numbers from A. Next one is complement of A union B. So we have to find A union B first. So I'm going to work on this one first. A union B means we have to combine all members. So writing all the members that we have inside A and B together. But do not repeat. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 15, 18. So we have all members. Now finding complement of A union B. This one is universal set minus A union B. The answer is all members except those members that are inside A union B. Okay, universal sets we have starting from 1 to 20. But I shouldn't have these numbers that they have for A union B. The answer is what's left. We have, so we don't have 1, 2, 3 up to this point 10. We don't have 12, we don't have 15, we don't have 18. What's left is 11, 13, 14, 16, 17, 19, 20. So this is the answer for A union B prime, or complement of that one. It's 11, 13, 14. And 20. What is the answer for complement of B? Yeah, so all the members that we have in the universal set, except those that are inside B. Right? So we have 1, 2, here we have 3, 6, 9, 12, 15, 18. And inside B, we shouldn't list these numbers. Next one is B minus A. So here again, if it's hard to find the answer, we can write this way. And this one is actually equal to B minus A intersection B. Or we can write B intersection A. It doesn't matter which one goes first. The A intersection B or B intersection A is 3, 6, 9 from this part. And we shouldn't have 3, 6, 9 to subtract those from B. So subtracting these, what's left is 12, 15, 18. If you didn't use that method, but try to subtract A from B, you have to work this way. The members that we have inside A, we have 1, but we don't have that in B. 2, we don't have that one in B. 3, we have that one. 4, we don't have in B, so we're not able to subtract. If you don't have the member in B, you're not able to subtract it, obviously. We have 6, so subtract that one. We don't have 7, we don't have 8, we have 9, so subtract it. We don't have 10, so what's left is 12, 15, 18. Again, it doesn't matter what's left here inside A. Do not list them. For this one, A prime intersection B prime, we have the answer for these two. So we have complement of A, we have complement of B. See what we have in common between these two sets. So we're working on these two sets, trying to find what we have, what the intersection one is. This one's starting from 11 up to 20, right? We have 11. Then we don't have 12, we have 13, we have 14. We don't have 15 in common, but we have 16, 17. We don't have 18 in common, 19, 20. These are the numbers that we have here. So these were members or elements that were in common between these two sets. It's asking to construct Venn diagram for the following sets. We have two sets, A and B. Before starting, we have to see if do we have any members in common between A and B? 2 in common, and we have 4. Now drawing Venn diagram. First, we have to draw this rectangle, which is universal set. One for A and one for B. Since we have intersection, I'm going to draw this way because I'm trying to write these numbers inside term 4 or inside the part that is in common between these two circles. And now we have to write the rest of these numbers. In B, we have 2, 4, and also 6, 8. Now in A, we have 2, 4, but also 1, 3, and 5. This was our Venn diagram for part A. Now part B, instead of 2, we have 3. So it's exactly the same. First, we have to find intersections. Now in this case, we have 3 sets, A, B, and C. I know that we have elements in common, that's why I'm drawing this way. Now I'll find intersection between all these sets. I'm starting with AB and AC, BC, and also between all 3 sets. Okay, first I will find between all 3. Well, let me just write this one on top. So here we have orange. This one and this one, that is the only one that is in common between all these 3. Now between B and C, between A and C, orange, we don't have anything else. What about A and B? Okay, now I'm going to start with the intersection between all these 3. And writing that one inside. Here is the part that is in common between all 3. So that is orange. Next one, between B and C, we have orange, blue. We already have orange between B and C, what's left is blue. So I'm going to write that one here. That's the intersection between B and C is this part. Next one, between A and C, we only have orange. So we already have that one here. Between A and B, yellow, orange. Is this port, that port inside, and also this one. So these are what we have in intersection part. Now we have to write the rest of these, starting with what I have in A. In A, we already have yellow and orange. We have to write red. And green. Now in C, we have blue, orange, purple, pink, but we only had orange, blue. So I have to also write purple and pink. And B, we had yellow, orange, blue. I have all these here. So this is our Venn diagram for part B. Now example number 3, draw a Venn diagram of the following. The first one is A intersection complement of B. Okay, so we have A and B, but B is complement. Since we are trying to find intersection between these, that means we trying to find what we have common in A and complement of B or PB prime. In other words, common to A but not B. First, what is complement of B? This is not the answer, I'm just explaining. So that is complement of B, anything except those that we have inside B. So all the members except the members that we have inside B. And also when I have here for A is this part. This is the part that we have in common. I'll redraw that one. To just have the final answer, the yellow part. Okay, so this is the final answer. Next one, part B is complement of B minus A. So we have to subtract all the members that we have in A from complement of B. Again, here we have complement of B. So first, I'm going to draw that one. So this is complement of B. Now subtracting all members that belongs to A. So here I have to erase these. I don't want to have any members inside. This part. Because these are the members that we have in complement of B. And I have to subtract them. Okay, so this is the final answer. So this one was asking to find elements in B prime, not in A. Next one is A union B, and we have to find complement of that part. A union between A and B means we have all these members. So we have to combine all the members that we have in two sets. And complement of this part is whatever that doesn't belong to A and B. So all members of site A and B. That's the final answer. So for union, you have to combine all members. But for the intersection, you have to find what you have in common. In high school, we have 46 students are enrolled in math or history class. 30 are enrolled in math class only, and 4 are enrolled in both math and history. How many students enrolled in only history class? So I'm going to first use values for math and history. I'm using M for math and H for history. So let M equal to so students enrolled in math, and H is for history. And I'm going to write what is given. We do have the number of elements in M and H, because here we have 46 students are enrolled in math or history. When I say or, that means we have to use a union. So this one is or, intersection is and. So math or history, we have 46. They are enrolled in math and 4 in both math and history. The number of elements in math are 30, and for math and history, which is intersection between these two, that is equal to 4. Now what is asking to find the students that are enrolled in only history class. So this one is number of elements in history. But if we try to draw Venn diagram, we can also see that inside that part, we're gonna have members that are in common. So if I wanna find members that are in history only, it's better to write this way. Minus those members that are in common between M and H. So this is what we need to find when we have intersection. So this part is only history. Now drawing Venn diagram, universal set first. Since I have the intersection between M and H is that one, I'm drawing this way. So that is H, and here is M. First, starting with what we have in common. So what is between these two circles is 4. Now to find the rest of that, for example, for this part, I have to use number of elements that are inside M, subtract the number of elements that I have in intersection part is M intersection H. So here for M we have 3, and here for intersection we have 4. So that is equal to 26. So in this part, we have 26. This is only math, is 26. Now do the same thing to find the answer for that part. How we can find that one? It says that we have 46 students total. So only history plus what they have in M, that is equal to 46. Only H plus for M we had 30 students. So this is equal to 46 minus . So this part, which is only H, is 16. So this was your final answer. So we can write it that way, or we can write 46 minus 26 plus 4, because we already had that part here, 4 and 26. We only need to subtract to find what we have in only H. That's 46 minus 30, and that is 16. Now, next part is asking for to simplify the following sets. If you had something like this, you don't need to draw it. If it's not asking you to draw a Venn diagram, you don't need to. You only need to write what the answer is. It's A intersection complement of A. As we have A and we have complement of A, and complement of A means universal set minus A. So we have nothing is empty set. But A union complement of A, that part is universal set. But I'm going to draw this one. Again, if it's not asking you to draw Venn diagram for these, you don't need to draw it. So complement of A is this part. And here is A. I'm using different colors so you can see, do we have any members in common between these two colors? So there is nothing in common, and that is empty set. If you want to draw this one, you shouldn't have these colors, and you have to erase them. If was asked me to draw them, then remember that we'll need to draw it. Need to erase these. Okay, so we have no members here inside. Now A union complement of A. So the answer is universal set. This is complement of A. And we have to combine that one with A. So A is this part. Now combining all. That is the final answer, so it's universal set. Now part C, A union empty set. So we have to combine all the members that we have inside A and also those members that we have inside empty set. We have no members inside empty set. For example, if I had A equal to 2, 3, 5, 7, but empty set is this one. There's nothing. What that means, union between A and empty set is again those members that we have inside A. So it's 3, 2, 3, 5, 7. The answer is A. What about A union universal set? The answer is universal set, because universal set is the largest set that we can have. And finding union, the answer is the largest set. So compare A and B, for example, you had two sets and you try to find union. You should have all members. If you had a set, something a universal set that you have all members inside that one, that means when you're trying to combine two sets, the final answer is the largest set that is given. So universal set is this one. So that is universal set.